Good morning and good afternoon. Hi, I hope you are all fine. My name is Muhammad Yusuf Iqbal from Pakistan. So I am here with a new lecture. Today we will discuss about the vibration analysis. So first of all, we should see our content in which we will study about the origin of the vibration, from where vibration comes. The second one is the basic concept of the vibration. We will study the basic terminologies of the vibration, frequency, acceleration, and while others third one is the significance of the vibration in the engineering, why it is so important in the engineering, in all engineering. And the fourth one is the simple harmonic motion, SHM. And the fifth one is the FFT, fast Fourier transformer, why we use the fast Fourier transformer. And the last one is the root mean square value. So let's start our topic about the vibration. So first of all, we will see the origin of the vibration. So first concept of the vibration given by the Pythagoras. He is a Greek philosopher and the mathematicians. He studied and he conducted so many experiments on the monochords. He also gave the concept about the pitch. So in this video, while video audio you are not listening, but you can see here is the monochord vibration strings have the would have the different strings have the different pitch, while the other is the given concept of the Galileo is also give the concept of the simple pendulum, and he gave the so many concept about the frequency, length, tension, and the density. He also gave a new book about the discourse concerning new sciences, and also found relationship between he also found the relationship between the pitch and the frequency of the vibration of the string. So let's start. What is the vibration? Vibration is the back and the forth movement of a structure. So also it is also the cyclical movement. We can see here is the vibration. We can see the vibration signal. So imperfection in the machine. What is the imperfection? Imperfection mean is the inaccurate, is the fault in the machine. So these are the some fault because of the design. So vibration produced. So after that we will discuss about how we can remove the vibration, and the importance of the vibration. The first one is the design. If the design is not accurate, then it produces the vibration. The second one is the assembly. Because of the assembly so many times it happen, the vibration comes. The third one is the manufacture, and because of manufacturing and the operation, installation, and the maintenance, these are the main factors because of producing the vibration. So in these factors, and the next we will study about how we can remove the vibrations. So here we can see that this one is the simple vibrations. We can see that the simple vibrations, and these are the complex vibrations. So don't be worried about later we will study how we can calculate the frequency, amplitude, and the time duration of the complex vibration. Here you can see that it is a simple vibration, so you can measure the easily. And here is also, but here you are a little bit confused how we can measure the complex vibration. So don't be confused. So later we will study about how we can calculate the complex vibration frequency and the while other parameters. So basic concept of the vibration, keep in mind these are the basic concept. Any motion that repeat itself after an equal interval of the time, these are the vibration. So the vibratory system consists of the three systems: spring, elasticity, mass or the inertia, and the damper. So they involve the transfer of the potential energy to the kinetic energy and the vice versa. So vibration is transferring the energy. We know that the energy can never be created nor destroyed. It just changed from one form to another form. So according to that concept, so vibration is also the changing the energy phase. It changed the energy phase. So we can see here the Hooke's law. We know that what is the Hooke's law? Hooke's law is the force that is the spring force is directly proportional to the distance, while K is the spring constant. Okay, so keep in mind here we can see that here if x is the distance is the x, then F is equal to minus kx, and if the distance is the 2x, then the force is also will be the double. So the spring force will be the double if the distance is double, because the force is directly proportional to the distance. So the next one is the common machine problems. Why vibrations generated in the machine? So these are the basic problems. The first one is the misalignment. We can see here the misalignment. Sometimes when the machines are not aligned, so after that it produces the vibrations. Okay. Then next is the unbalance. Sometimes machines are unbalanced because of the so many factors. They are not proper balancing. The next one is the worn belt and the pulleys. Sometimes pulleys and the belt in which producing the wear and tear. So after wear and tear, it also produces the vibrations. So also the bearing defects, hydraulic forces. These are the all parameters, all because causes of the vibration and producing the vibration. So the significance of the vibration in the engineering, in the all engineering, the first one is the if the high speed engines we see that, or the turbines, they are also subjected to the vibrations. Like if high speed engines, if in this have so many vibrations, then like your engine will be not will work properly, it will not give you the maximum efficiency. So we should study first about the vibrations. And because of the vibrations, sometimes your machines is not work longerly for a long time. So that's why vibration is so important. So you should study about it, and you should try to remove the vibration in all your machines or engine. The next one is that due to the fault design and the poor manufacture, there is an unbalancing in the engines. They are also producing the vibration. So try to remove that. And the next one is the vibration causes the rapid wear of the machine parts such as the bearing and the gears. Unwanted vibration, losing of the parts, these are all. So the next one is the many buildings in the structure or bridges fall because of the vibration. You know that when your resonance frequency excitation frequency when meets with the natural frequency, then it become a new phenomena that is called the resonance. Then when resonance occurs, then your is a big frequency is created, and that frequency cause of damaging of your model of your bridge or any of the building. So in this picture you can see the is a falling a bridge because the frequency is matched with the natural frequency, exciting frequency with matched with the natural frequency and producing the resonance phenomena. So the next one is the vibrations can be used for the useful purpose. Also the vibration testing equipments, vibratory conveyors, hoppers, and the compactors. The next one is the vibration is found very fruitful in mechanical workshops such as the involving the efficiency of the machining, casting, forging, and the welding technologies. It is also used for the propagation of the sound. How we can eliminate the vibrations? There are the three methods in this we will study. The first one is the using the shock absorber. By using the shock absorber, we can remove the vibrations. You know that in the vehicle, it's that we use sometimes hydraulic shock absorber. Hydraulic shock absorber are the electromagnetic regenerative shock absorber. There are so many shock absorber you can use, and after using that shock absorber, we can recover that energy and we can give the stability to our model. So this one is the first step to using by using the shock absorber to remove the vibration. So the second one is the dynamic absorber. The third one is the testing the system or the proper vibration isolator. And these are the three parameters that we can remove the vibration. The basic terminology. Now we will discuss about the basic terminologies of our vibration analysis. So first one is the periodic motion. What is a periodic motion? A motion which repeat itself after equal interval of the time. A motion which repeat itself after equal interval of the time. Okay, it is called the periodic motion. Please try to remember these terminologies. A motion which repeat itself after equal interval of the time. The next one is the time period. The time taken to complete one cycle. If the one frequency is completing 1 second, that is it's called the time period. T. T is equal to time taken to complete one cycle. Like this one is the frequency, it complete in one cycle, it is called the time period. The next one is the frequency, number of the cycles per unit time. It is called the frequency. F is equal to 1 over T. F is equal to 1 over T. It means number of the cycles per unit time. Again, I am repeating F is equal to 1 over T. It means the frequency. Amplitude, the maximum displacement of a vibrating body from its equilibrium position. While the natural frequency, when no external force acting on the system after giving it an initial displacement, that body vibrates, that is called, after that is get the natural frequency. Like in a simple pendulum, when we move a ball, after giving the force, it rotate itself. We are not giving the external force. Okay, that is called the natural frequency. Fundamental mode of the vibration. The fundamental mode of the vibration of the system is the mode having the lowest natural frequency, have the lowest natural frequency. So in this diagram, we can see that the upper portion is called the crest. Okay, the upper portion of the frequency is called the crest. The lower portion is called the trough. Crest and the trough. This one is the amplitude. We know that the maximum displacement is called the amplitude. So the frequency and the time period, f is equal to 1 over t, and this one is the wave frequency we can see here. So this one is another flow chart between the, we can see that here is the compression and the rarefaction. The number of the frequency is so many, it is the compression. Here is the rarefactions, the number of the frequency is less here. The next one is when you put a ball or a stone in a water, we can see that there is a ripple of the water, like this. These are called the also the frequency. It produce the frequency like this. Floating object, this one is a floating object, and this one is a ripple, so it produce the wave. It produce the wave. We can see here the different frequency have the different wavelength and the different propagation. This one is the phase shift of our wave. Well, the next one is the simple harmonic motion. What is the simple harmonic motion? What is the SHM? The motion of the body to and fro about a fixed point is called the simple harmonic motion. The motion of the simple pendulum is simple harmonic in nature. T is equal to 2 pi under root I over mgl, while I is the moment of the inertia, m is the mass, g is the gravity, and l is the length of the string. So we can see here why from here is a fixed point. There is a ball, and when we leave it, then it rotates itself, and after equal interval of time, it will be a stop. Okay, after the natural frequency, of getting the natural frequency, and we can measure the time period by this formula, and frequency also we know that f is equal to 1 over t. Amplitude is the maximum displacement. Okay, but in term of the engineering, we can measure in velocity, acceleration, and the displacement. Mechanical vibration is created when one body moves relative to another. So in the next slide, in the next few slides, we will see that where we can see we can measure the velocity, where we can measure the acceleration and the displacement. They have a different range of the frequency. Okay, we can measure where we can measure the velocity, acceleration, and the displacement. Acceleration, you have already studied, it is so easy. You have studied in the college level, might be in the school level. Acceleration, the rate of the change in the velocity over a period of the time. The rate of change of the velocity, dv is equal to dt, like v2 minus v1 with t2 minus t1, that is called the acceleration. The next one is the basic terminology, in which we are studying the frequency. Frequency used to vibration analysis relates the number of the times a cycle repeats itself. I am repeating again the definition of the frequency. Before that, I told you that F is equal to 1 over T. Number of the cycles per unit time is called the frequency. Number of the cycles per unit time is called the frequency. In case of the rotating shaft, it would be the number of the complete revolutions the shaft makes during a minute. So in frequency, there are the different units. The first one is the revolution per minute. If you want to measure the RPM and you have just a frequency in hertz, then how you can measure the RPM? You just multiply with the 60. Then you can called the revolution per minute. It is called the revolution per minute. RPM mean revolution per minute. So if suppose you have a 2 hertz frequency, and your teacher or someone is asking what is the RPM of this frequency, then you just multiply by 2 by 60. That is called the RPM. 2 multiplied by 60 is equal to 120 RPM. Okay, remember him. The next one is the significance of the frequency. Now we are discussing the significance of the frequency. These are the frequency range. Like if the frequency is very low from 5 hertz to a 200 hertz. Okay, if 5 hertz, then can you measure in RPM? Yes, it's so easy. If the 5 hertz is measured in the RPM, that just multiply by 5 multiplied by 60, what is equal to 300 RPM. Very good, excellent. If the frequency of the vibration is low, then 5 hertz to 200 hertz, then we can measure the displacement. If the frequency is so high, 2000 hertz, then we can measure the directly acceleration. If the frequency range is 100 to 2000 in the middle, then we can measure the velocity. There is, we can see that again a significance, 5 hertz to 200 hertz. Keep in mind, remember this one is so important. 5 hertz to 200 we can measure the displacement. 100 hertz to 2000 hertz we can measure the velocity. The 2000 hertz to above we can measure the acceleration. So these are the flow chart of the frequency: low, medium, and the high. Next one is the fast Fourier transformer. So what is the fast Fourier transformer? In the start I have told you that don't be confused, don't be worried. We will measure the complex vibration, frequency, amplitude, and we can measure all variable of the complex vibrations. I have told you, do you remember? Of course you are remember. Okay, so now we are measure the complex vibration. Complex vibration frequency, acceleration. How we can measure? This one is the method fast Fourier transformer, in which it is discrete the Fourier transformers, like a mathematical process and a logarithm that transfers a waveform into a components to a frequency spectrum, and also the input signal from the time waveforms. It also give the signals. Okay, so this one we can see here. This one is the fast Fourier transformer, discrete Fourier transformer. This one is the complex, and here we can measure easily amplitude, frequency. We can measure any variable from this. Here is another vibration machine vibration, in which by using the sensors we can, these are the sensor we can see here. These are also the sensors. Vibration level meter are the sensor, and the sound level sensor, and after that we getting the computer, and the we can get the data, and after that we can measure the vibration. But nowadays is also technology, directly we can measure by using the sensors. We can measure directly the vibration, but we can also remove the vibration. You know that how we can remove that? By using the shock absorbers. We can use them by the dynamic absorbers, you know that. Okay, and by you can see here is also the and another sensor we are using here in the motor, and we can get the uh, transducer signals. If the vibration is so high, then you can see it's mean here is some problem, maybe a wear and tear problem, maybe a misalignment problem, maybe a some other problem. So you can remove that problem, and your machine will give you a maximum efficiency. Okay, this one is the SPM shock pulse measurement instrument. Here we can also use the overall vibration. We can see here this is a parameter, overall vibration, unbalancing, wear conditioning. So these are all parameters we can measure from this device. Okay, so the last topic is root mean square value. Okay, the last is the root mean square value. Root mean square value is the quadratic mean. Also it is also the quadratic mean. So the root mean square value is the direct current that gives you a maximum, that gives you average power dissipation in their resistance. Okay, there is the root mean square value. It is the most important characteristics of the sine wave. the RMS or the effective value. The abbreviation RMS stand for the root mean square value, and it is determined by the VRMS is equal to 0.707. If you wanna measure the voltage, then V mean voltage, root means square value. If you wanna measure the current, then I is equal to RMS. RMS is equal to IP. The next is the graphic method. By using the graphic method, we can measure the root mean square value. Root mean square value, the sum of the mid ordinates. Like this one is the first value, V1, V2, V3, V4, V5, V6, V7, V8, and V12. So all of the square, V1 square plus V2 square plus V3 square, and divided by total number of the, these are the 12 and these are the 12, then we can measure the voltage. These are the RMS by using the graphical method. The next one is the analytical method. If the peak value 1 over 2 under root multiplied by the peak value in this, can you see which one is the peak value? Peak value is the V6. You can see here. V6 is the peak value, and we can multiply by the 1 over 2 under root, then is also called the root mean square value. If root mean square value 1 over 2 under root into 2 under root 2 into 2 under root multiply by the peak to peak value, like this one is a peak to peak value. Peak to peak value is also we can multiply 0.3. It is also called the root mean square value. If you have a average, then you can multiply with 1.1. So by this method, we can calculate the root mean square value. Okay, like if you have a peak to peak value, if you have a just a peak value, if you have an average value, then you can measure the root mean square value. Okay, get it? Thank you so much for listening. So I think so a little bit dry, but try to understand it. Okay, if you like it, please share this video. Thank you so much.